An array is a linear data structure which is a collection of data items having similar data types stored in contiguous memory locations. By knowing the address of the first item, we can easily access all items/elements of an array. Arrays and its representation is given below. Array index. The location of an element in an array has an index, which identifies the element. Array index starts from 0. Array element. Item stored in an array is called an element. The elements can be accessed via its index. Array length. The length of an array is defined based on the number of elements an array can store. In the above example, array length is 6, which means that it can store 6 elements. When an array of size and type is declared, the compiler allocates enough memory to hold all elements of data. For example, an array face 10 will have 10 elements with index starting from 0 to 9, and the memory allocated contiguously will be 20 bytes. The compiler knows the address of the first byte of the array only. Also, the address of the first byte is considered as the memory address for the whole array. Normal variables, a 1, a 2, a 3, can be used when we have a small number of elements, but if we want to store a large number of elements, it becomes difficult to manage them with normal variables. Representing many elements with one variable name is the basic idea of arrays. Why does array indexing start with 0? Let's try to understand this by taking one example. Assume we can declare an array of size 10 in the following way. Int a, 10. Here itself is a pointer which contains the memory location of the first element of the array. Now for accessing the first element, we will write a 0, which is internally decoded by the compiler as *a plus 0. In the same way, the second element can be accessed by a 1 or *a plus 1. As a contains the address of the first element, so for accessing the second element, we have to add 1 to it. That's why here we have written *a plus 1. In an array, the index describes the offset from the first element, i.e. the distance from the first element. Now let's assume that array indexing starts at 1 instead of 0. In this case, for accessing the first element, we have to write a 1, which is internally decoded as *a plus 1 to 1. Observe here that we have to perform one extra operation, i.e. subtraction by 1. This extra operation will greatly decrease the performance when the program is big. That's why to avoid this extra operation and improve the performance, array indexing starts at 0 and not at 1. Array operation. Now that we know the basic idea behind an array, let us now look at the various operations that can be performed on arrays. Traverse. Print all the elements in the array one by one. Insertion. Adds an element at the given index. Deletion. Deletes an element at the given index. Search. Searches an element in the array using the given index or the value. Update. Updates an element at the given index. The various types of arrays are as follows. First, one-dimensional array. Second, multidimensional array. One-dimensional array. A one-dimensional array is also called a single-dimensional array where the elements will be accessed in sequential order. This type of array will be accessed by the subscript of either a column or row index. Multidimensional array. When the number of dimensions specified is more than 1, then it is called as a multidimensional array. Multidimensional arrays include 2D arrays and 3D arrays. A two-dimensional array will be accessed by using the subscript of row and column index. For traversing the two-dimensional array, the value of the rows and columns will be considered. In the two-dimensional array face 3, 4, the first index specifies the number of rows and the second index specifies the number of columns, and the array can hold 12 elements, 3 by 4. Similarly, in a three-dimensional array, there will be 3 dimensions. The array face 5, 10, 15 can hold 750 elements, 5 by 10 by 15. A linked list is a sequence of data structures, which are connected together via links. Linked list is a sequence of links which contains items. Each link contains a connection to another link. Linked list is the second most used data structure after array. Following are the important terms to understand the concept of linked list. First, link. Each link of a linked list can store a data called an element. Second, next. Each link of a linked list contains a link to the next link called next. Third, linked list. A linked list contains the connection link to the first link called first. Linked list representation. Linked list can be visualized as a chain of nodes, where every node points to the next node. As per the above illustration, following are the important points to be considered. First, linked list contains a link element called first. Second, each link carries a data fields and a link field called next. Third, each link is linked with its next link using its next link. Fourth, last link carries a link as null to mark the end of the list. Types of linked list. Following are the various types of linked list. First, simple linked list. Here item navigation is forward only. Second, doubly linked list. Here items can be navigated forward and backward. Third, circular linked list. Here, last item contains link of the first element as next, and the first element has a link to the last element as previous. Basic operations. Following are the basic operations supported by a list. First, insertion. Adds an element at the beginning of the list. Second, deletion. Deletes an element at the beginning of the list. Third, display. Displays the complete list. Fourth, search. Searches an element using the given key. Fifth, delete. Deletes an element using the given key.